Hello everyone. My name is Aayush Kumar, and today I am presenting my presentation for Liquid Galaxy Task 3. So my topic is Beyond Visuals, making Flutter apps truly accessible. So basically, uh, I will try to show you the methods of accessibility in Flutter apps. So let's start the presentation. So let's start from introduction to accessibility. So basically, what is the accessibility is? It is the design and development practices that ensures apps are usable by everyone. So, what we mean by everyone? Here, everyone means that we also include the people with disabilities. There are some form of disabilities in some people, like maybe they are visually disabled, audible disabled. So we have to take care for them while designing and development of the apps. Uh, so this includes features like screen readers, voice commands, adjustable text sizes, color contrast options, and more. We have seen the talkback feature in Android and voice command features. Uh, Nowadays, every AI also uses voice commands. So Flutter is committed to supporting developers in making their apps more accessible and includes first-class framework support for accessibility in addition to that provided by the underlying operating system. So Flutter provides many frameworks for the accessibility, many widgets for the accessibility. So we will see them and how to implement them in our applications. So why this accessibility matters? Or why we will change our applications for some people? So here the thing is that we can see the data. There are 1.3 billion people estimated by the WHO that an estimated 1.3 billion people, or we can say the 1 in 6 people worldwide, they experience some kind of disability. So maybe this kind the disability does not include only the visual and audible disabilities, but there will be a large number of people uh, who also suffer this kind of type disabilities. So the first thing that why we use accessibility and why accessibility matter in our applications is inclusivity of all users. So we are including these users also in our applications that they also can experience our apps. And then the second one is legal and ethical responsibility. So the UN Convention for the Rights of Persons with Disabilities states the moral and legal imperative to ensure universal access to information system. So this UN Convention on Rights of Person with Disabilities, they ensure that uh, the network information it is reached to every person, even they are disabled. So it become our legal and the ethical responsibility to make our application by the point of view of that persons also. So third point is this will expand the user base. So it also a good thing for the company that our user base is also expanding by including the person with disabilities, enhancing the UX for everyone. So by using the accessibility features, user experience also increases. So the people with disabilities can also use our apps, and then the building a positive brand image. Also, this will build a reputation and a positive brand image for the company that they are also including the persons with disabilities. Um, the next one. Now, what kind of accessibility features that Flutter includes? So basically, Flutter has three components that provide accessibility supports. Uh, the first one is large font. So we can use the large font sizes so it is better visible to the person with some kind of visible disability. So let's see a chart which shows this. So in the material library, these are some font sizes. So like we have to display a large thing, then this is the sizes, regular sizes. You can see them. Now the second is sufficient contrast. Now contrast matters because like we are using the some random colors on some random background. It may happen that like here are the examples, bad examples and good examples. That we have a black background and we are using this some dark blue kind of color. So blue on black. So this is a bad contrast example. But the text is not visible even to a normal or a person with no disability can't see that clearly. So, but here the good example is that if we use a yellow on black, this is considered to be a good example. So, if we focus on the colors, it can also help a lot to the users. So, next time, uh, careful about that colors. The third thing is screen readers. So, like uh, I talk about the talkback feature in Android. These are the screen readers that some user tap on the screen and the uh, device will read that for you. So this helps uh, the person with disability to read that. If they can't see the thing, they can listen to that thing. Uh, Now W3C, which is World Wide Web Consortium, it recommends that for the small text, there should be 4.5 is to 1 ratio. So below 18 point is regular or 14 point bold. These are some text font sizes which the W3C recommends to us. Now, now let's look at some of the things you can do with accessibility and improve the user experience for the persons, all kind of persons, not only the person with disabilities. It also enhances the user experience for normal users also. So now, first, declare header element. Uh, I think every one of us have used the uh, MS Word. So there is one thing, header and footer on the page. So this header, uh, it helps us to like declare that what the page is about. So every screen is in your application, so try and declare a header to provide clarity about the function of that page. That what the page is about. What is the function of that page in our application? If you use material app bar, then it will be set automatically. Otherwise, you can use the semantics widget of the Flutter to declare the header. That what is the header. So here's the code example of that thing that in the semantic widgets. This is the widget that we will use for the accessibility features. Uh, so here the header, which is a Boolean type. It will be true if you are marking that this is the heading for the accessibility. So when we are using the talkback feature, so this will be the heading for the page for that. And then this is just the child where we put a text. So like my title. So the talkback will recognize that this semantic widget or this page have a header and I have to read that for the user. So declaring header element is the first thing that we should use to make our application accessible. Now, second thing, require semantics for buttons. Now, buttons are very essential for the user interaction. So user mainly interacts with our application using the buttons. Oh, sorry. So we should and we must use the semantics for buttons. So it is a good practice to create a custom button or gesture detector for our app with a required semantic label parameter and use it everywhere. So our button should have a semantic label that whenever uh, user click on that, the will talkback feature or the voice feature will read for the user. So this is a basic structure of that button. So like there is a app button. So it has a required semantic label. So this is a custom button. Okay. So it has a on pressed event and it has a child. And the main thing that it has a semantic label. This semantic label will read, the talkback will read this whenever we click that button. So the next thing is use live region. So live region, like you are turning a page and the talkback will automatically read the content of that page. You want to implement this type of function in your app. So then you will use live region. So it is often desired to have content read automatically to the user as the result of some action. So in this case, we will use semantics.live region. So this is basically the example of semantic live region. So just it is a Boolean. So we have to mark it true, and then we can just add our child in that. And now move to next one. The fourth one is using on increase and on decrease. So this is also the semantics feature. With the combination of live region and the increase and decrease handlers, the user will be able to select the page view, flip up or down, and have the content of each page read to them. This will vastly improve the user experience in this situation. So basically, what is the uh, here that like there is a simple page view, and I click or I move to the next page. So then on increase function and on decrease function, they will declare that what will happen when I will move to the next page. So in the code example, so on increase, it is a event called begin. So here the set page index, the index will be increased to 1 when I am clicking the next button. And on decrease, the index will be negative 1. So, and we can use the live region also with this. So when we are moving to next page, its content also automatically read by the talkback feature. Now move to the next one. Use merge semantics. Basically, when the semantics are created, they use the tree data structure for the creation. So Flutter will create a semantic node for all the text widget by default. We also see that for the normal widgets, there is also a tree type thing. So for the same semantics also, a tree is formed, but it will not understand. Flutter will create a semantic node for all the text widget by default, but it will not understand anything about how to group them. As a each element will be read individually, uh, which will create poor user experience. Now, what it to try to explain you that we create like here in the image, you can see there are some tabs in the app. Now, what will happen that when I move to this, my talkback doesn't know that how these things are grouped together. So merge semantics, they're the merge semantic works that we will tell the app that how we will arrange them and how you have to read them. So merge semantics, using merge semantics here, like there are two childrens here, the checkbox and the text. Like there is a setting checkbox. So talkback feature doesn't know that first we have to read the setting, and then like there is a home tab. So then I have to read home, and I have to read your content. So Flutter doesn't know that. So we have to uh, declare that these are merged things, and you have to read these things only together and the other things separately. This is the merge semantics. Basically, we are merging the things that these are in a one tree and one tree node, and the other thing is in another tree node. Hope you understand this. Then the sixth one is ignore pointers. Now we want some things in our app that should be ignored by the app. So there must be some cases, there would be some cases in which the user uh, by mistake click on some things. Oh, in that case, we want to ignore their functions. So ignore pointer logs both touch interaction and semantics by default. So by default, it blocks both the things, touch interaction and also the semantics. But that's not always good. We don't want to do that thing always. So in that case, we are using the ignore pointer dot ignoring semantics. So using this ignore pointer, you have to be careful that if you are just using the ignore pointer and do not declaring that what you have to ignore, then it will by default ignore both the things. So like here is the example, uh, ignore pointer, and we are marking it true, and there is a button. And on pressing the button, it should increment the counter. But if we want that on pressing, it doesn't do anything, then ignore pointer will work here. So here, if I click this add button, there is no function that will happen by this button. So this is the function of ignore pointer. Just you have to be careful about ignore semantics also. That if you want to ignore the semantics, just semantics, then you have to include the ignore pointer dot ignoring semantics. Move to next one. Use exclude semantics. So sometimes you have elements on the screen that has no semantic labels, like a background image. Uh, so there is a page and there is a background image in that page. We don't want to read it, read the path of that page or some semantics of that page by the uh, talkback feature. So in that case, it is beneficial to remove that node. So I told you that it is basically a tree. So we will remove that node using the exclude semantics. So there is a semantic tree. We want to remove a node or a semantic from that tree. So we will use exclude semantics. This is the simple thing. So here's the example, like here's a stack of things, and we use exclude semantics. Moving to the next one, properly implement tab menu. Now we want, when creating a custom tab menu, it is important to provide a label to each button that indicates it is a part of a larger menu. So there can be large number of tabs in the, like here in the example, there are three tabs. So we want to tell the user that you are on the second or out of three, or you are on the third out of three. So this will be, you have to consider it for the user. So you have to provide a label to that button, tab button. So there is a material localization which provides the standardized to build this label. So this is the syntax of the material localizations dot of context. We will use a context here. Then we will give the label. So tab label is localizations dot tab label, tab index. The tab label will be given by the index of the tab, and the total tab count is tabs dot length. That what are the total number of tabs. So it will prepare a label for the tab based on the index of the tab. And when we are creating that button, we just give a label that this is the tab one or image gallery. We have a image gallery and 10 number of images are there, and we move to the second image. Then the semantic label here will be image gallery and the label of that tab. like second image, third image. So this will help a lot for to the person who cannot see uh, which image on which image we are. So he can or she can hear that thing that we are on the fifth image out of 10. So this will help a lot. Now, next one is fully describe semantic elements. So it is important to really analyze the various visual cues in your app and try fully describe what information they are imparting to the visual user. So while developing the app, uh, you have to think with the point of view of the user who can't see that. You are the visual user, but you have to think with the point of view of that user who can't see that. So you have to provide the semantic element for that. Like here's a basic example. For the visual user, he can see that there is a heading Jackie's cake, and there are some button here, and the cupcake menu is there. So what we can infer from this page, we have to tell the user uh, who can't to see that. So we have to describe our semantic elements for that user who can't see that. So like here for the Jackie's cake, we provide a semantic label Jackie's cake for the first image. And now we see that it is a cupcake or chocolate flavor with chocolate flavor, and when we click on it, there is some function like we can go to the cart or something. It will be added to the cart. So our description is cupcake flavor is chocolate, and it is a button. Above it is a button. On clicking, it will be added to the light menu. So we can see that these are the flavors: chocolate, red velvet, and Oreo. But the user who is a disabled person, uh, he can't see that. So we have to provide the description for him. So think using his or her point of view. Now, careful about minimum size of semantic elements. Now, you have to use a standard size for the all the users. So not only the users who can't see them, but think about like I can't see too much small font also. So I have to think by myself that I have to provide a basic minimum size. So one of the primary ways to discover UI for a screen reader user is to drag a single finger around the screen to discover semantic nodes. So like there is a widget and it is so small that when I click, there is no touch interaction there. So I have to make it at least 42, 32, 40 pixels so that uh, it can be touched by the user and there is some function on that. So if it is too small, this means that very small semantic nodes can be hidden from the user. So try to have a minimum size of 30 to 40 pixels for all semantic elements and allow them to take up unused vertical or horizontal white spaces where it is makes sense. This will result in an interface that is friendlier to users of a screen reader, saving time and frustrations. So like I want to click on a button, but it is too small that it can't be clicked, and there is no function of that button, and it is in the extreme corner of the app. So you have to think while designing your app. So what is the size and what is also what is the position of that button. So this is all. Let's conclude it. So making your app accessible to more people is a huge win for everyone. And hopefully these tips helps to make it easier. So you can use these tips, use these uh, features of Flutter in your app. So by making accessibility the default and implementing it from the start of your project, and you'll find it happens naturally and requires fairly minimum additional effort. So you have to just add semantic widgets and some labels, and it will be a load for the person with some kind of disability. You are gaining to like additional insights on the structure and usability of your app for the sighted user along your way. So you are impacting the society by your just small changes. You have to add a widget only, and you can impact the society. So thank you. This is from my side. Kumar. Let's meet in the next presentation. Thank you.